Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ashraf bin Muhammad, S49100, and my supervisor is Dr. Nazri bin Husin. And I am doing dynamical systems, so my topic is dynamics interaction between the growth of phytoplankton and nutrients. So for the introduction, what is dynamical system? Dynamical system is one state evolved into another over the course of time. So examples of dynamical system is climate and bathtubs and a lot more. So for the attractor, the meaning of attractor is the tiniest unit which cannot be broken down. So in order we want to study attractor, we have to know the invariant sets of stability first. Okay. So the next is functional response hauling type, which is it has three classification: types 1, type 2, and type 3. This is the number of prey successfully assigned per predator as a function of prey density. So we have phytoplankton blooms and nutrients. Phytoplankton bloom is happens when there is excessive of nutrient, and some example of nutrient is nitrogen, phosphorus, iron, sunlight, and carbon dioxide. And from a problem statement, we all know that phytoplankton is can be dangerous if it is excessive of the level. So this study wants to authorize a dynamical model based on the impact of temperature and light on the density of phytoplankton and nutrient. Okay, so I find the equilibrium point and the stability analysis for the equilibrium point. So the objective of my study, first to modify the model of nutrient phytoplankton from Michaelis Menten function and hauling type 2 to hauling type 1, and then to prove and obtain positivity of solution of the model because this is a biological model, and to find equilibrium points of the model and analyze the stability of equilibrium point. Alright, done some research on a few papers based on this topic. So I have Edwards in 2001 about the dynamical behavior of simple plankton and population model. I also have Greta and Ferroa in 1996 about the model for the simulation of microalgae, and Chen et al. In 2015 about the dynamics of temperature and light on the growth of phytoplankton. And this is the paper that I have been studied for my topic. Okay. So for the methodology, I have modified in the model. So I modified the model from Chen et al. That I have said earlier based on a few assumptions such as the loss of phytoplankton, it is proportional to its density, and the exchange of nutrients can occur with the external water is proportional to the phytoplankton uptake of nutrients. Okay, so this is Chen model. I have modified this model to hauling type 1. So for the second methodology is positivity. I have to find the positivity of the model because it is a biological model. So the method I am using is integrating the model with respect to T. And for the third one is equilibrium points and stability analysis. To find the equilibrium points, I have to make the equation equal to 0 and find the simultaneous equation. And for stability analysis, I use Jacobian metric to find the agent's value. Okay. So we go to results and discussion. Okay, for the first one, the modified model. So we modified model from Chen et al. From Michaelis Menten function and hauling type 2 to hauling type 1. So this is my model. And we have parameter mu, g, h, m, b, a, s, and p. So this all the parameters we have fixed the value, and this is the model that I am doing, that I have modified. So for the next one is positivity of the model. To find the positivity, I am integrating the equation with respect to t. So after I integrate the equation, I have exponent value. So this means if any value that we put in t and a and p, we got it's positive. So the equation is positive. For the second equation, I also integrate it with respect to t. So if we put so I also got the exponent. So if we put all the numbers, every numbers here, it will be positive. Okay, for the last one is equilibrium point and stability analysis. As everyone know, if you want to find the equilibrium point, we have to make the equation equal to 0 and solve the simultaneous equation. So I have three equilibrium points, E0, E1, and E2. For stability analysis, every equilibrium point, I do Jacobian matrix and find the eigenvalue. For equilibrium point 1, I have asymptotically stable. For equilibrium point 2, I have also asymptotically stable. And for the last one also, for the last one is saddle, because one of the eigenvalue is greater than 0 and the second one is lower than 0. So for the conclusion, as this model has been modified from Chen et al. And all the parameters value have been fixed. So I have to find the positivity, equilibrium points, and stability analysis for the model. And I hope someday a few researchers will be interested to explore more about this model and all the parameters, so we can have a strong evidence about this topic. So thank you.